Hello guys, and welcome back to my video. So if you've not subscribed to this YouTube channel, please make sure you subscribe and click the thumbs up button so that you help me create more content. So guys, I'm very sorry for not releasing content. For the past few weeks I've been busy with exams. So today we are going to look at the logistic regression algorithm. So let's first take a look at this scenario. So let's say you want to predict if a person is at disease based on their cholesterol level. So one way of doing that would be to use a linear regression model. So if you have not watched my previous videos about linear regression, I advise you to do so that you can understand where this is coming from. So let's take a look at this. So let's say we want to predict if someone has heart disease based on their cholesterol level. So this is heart disease. So let's say we have these data points here, and these data points here. So one way of doing this would be to use a linear regression model, something like this. We use a linear regression model, something like this, and then after using a linear regression model, we can then use a threshold classifier. So if you remember, the hypothesis for our linear regression model was h theta of x is equals to theta transpose times x. So our threshold classifier will be if, let's say, if h theta of x is greater than or equal to 0.5, then we'll predict that y is equals to 1, or yes, or the person has heart disease. So if our threshold h theta of x is less than 0.5, then we would predict that y is equal to 0, or the person doesn't have heart disease. So this is the threshold, 0.5. So points on this right side are classified as 1. So points from this right side, these points here, are classified as a person who has these features are classified as a person who has heart disease, and then these features are classified as a person who doesn't have heart disease. But there is one drawback of using the linear regression model. So let's take a look at the drawback. So let's say that we have these data points here, and then let's say here we have these data points, and we have other data points that are further away. Let's say we have data points here. So let's extend our line up to somewhere here. So if we draw our linear regression model, that would be something like this. And then using our threshold that we used in the last example, this is the threshold. Let's say this is the threshold in our last example. You can see that now the linear regression model is now misclassifying some of the examples. You can see that this example is now being classified as someone who doesn't have heart disease, but this feature falls under someone who has heart disease. So how do we solve this problem? So to solve this problem, that's where comes in what we call the logistic regression. The logistic regression or the logistic function. So let's first define the hypothesis for the logistic regression model. So the hypothesis for the logistic regression model is h theta of x is equals to g, our theta transpose, times x. So in this case, g is equal to 1 over 1 plus e to the power negative z. So also we can, that's g of z. So we can substitute this into z. So that becomes g theta of t transpose x is equals to 1 over 1 plus e to the power negative theta transpose times x. So this is what we call this is the hypothesis for the logistic function. So let me draw the logistic. This is called the logistic function. So this is called the logistic function, or the sigmoid, function. So let me draw the graph for this function. So the graph for this function is something like this. So the logistic function is H-shaped. So this, the y-axis, represents our hypothesis h theta. Represents our hypothesis h theta is equals to g theta t transpose times x. So this axis represents negative z, this axis represents positive z. So z ranges from negative infinity up to infinity. So this is the graph for the logistic function. So how does this logistic function solve the problem that our linear regression was making of misclassifying examples? So let's check this out using the example we used when we first talked about the linear regression. So we are trying to predict if someone has heart disease. So it should be like coronary heart disease. So this is the cholesterol level. So if we draw these examples, then our logistic regression function will be something like this. So this is, let me erase here, I made a mistake. So the logistic function will be something like this. It's sort of like S-shaped. I'm sorry about my poor drawing, but it's something like this. It's S-shaped. So what the logistic function does is predict if something is true or false. So this type of a problem we are trying to solve is called a binary classification problem, where we are trying to predict if someone is at disease or not. So we represent if someone is at disease, which is yes, we represent it by one. We represent it with 1. If someone does not have a heart disease, we represent it by 0. So what the logistic regression does is predict if something is true. It means if someone is at disease, that's 1, which is true. If someone doesn't have a disease, that's 0, which is false. So that's what the logistic function does. So the logistic function is S-shaped, and also this curve tells us the probability of someone having heart disease based on their cholesterol level. So this is the probabilities. These are the probabilities. They range from 0 up to 1. So what this curve does is it tells us the probability of someone having heart disease based on their cholesterol level. So let's say if we take this example here, let's say it's somewhere here. So let's say this is around maybe 0.8. So this tells us based on this cholesterol level, there's an 80% chance that this person has heart disease. So that's what the logistic function or this curve tells us. So in this case, so this is 0.5. So in this case, if the probability that a person has heart disease is 0.5, we classify that person as having heart disease. If it's less than 0.5, that person is classified as not having heart disease. So I hope you guys understood what is the logistic regression and how it is used to classify, how it is used to solve problems such as the binary classification problem. So in this case, we only used one feature, but logistic regression can also have multiple features. We can also determine if the person is heart disease using the cholesterol level, the weight, let's say the weight, and then let's say we can also use the blood pressure, and then we can also use the chest pains, if the person has chest pains, to determine if the person has heart disease or not. So thanks for watching, guys. I hope this video helped you understand more about logistic regression. So if you have not yet subscribed to this YouTube channel, please subscribe and turn on the notification bell on so that you don't miss any of my videos. Thanks for watching, guys. Cheers.